My name is Siti Rabiatul Adawiyah binti Mahadzir and my metric number is 158881. I am student from School of Physics and student of 2021 and 2022. My job in this video is script writer.
Hi, my name is Hanim binti Ahmad Sharifudin. My metric number is 157977. I am a first year student from School of Physics. My job in this video is an editor.
Hello everyone, my name is Natasha, Aliah binti Balia Harun, matrix number 158392, first year students from Schools of Physics, year 2021-2022, and I am your presenter for today's presentation. Electromagnetic Crane. Do you guys know what it is? No? Here, come join me to hear an interesting story and more details about it. In 1825, a British electrical engineer, William Sturgeon, a former soldier who began dabbling in science at the age of 37, invented an electromagnet. His invention only came 5 years later after a Danish scientist discovered that electricity emits magnetic wave. William Sturgeon took this concept and demonstrated conclusively that the stronger the electric current, the stronger the magnetic force. Electromagnetic crane is used to handle and move metals like steels and iron. This crane can be found mostly in recycling plants and scrapyards. His first invention in electromagnet is horseshoe-shaped iron wrapped in a loosely wound coil with several turns. When a current was passed through the coil, the electromagnet becomes magnetized, and when the current is interrupted, the coil demagnetizes. He demonstrated its strength by lifting 9 pounds with a 7-ounce piece of iron wrapped in wires that carried the current of a single-cell battery. The electromagnet controlled by adjusting the electrical current, which changed the magnetic field. Let's move on how this crane works. The magnet is turned on and off when needed by the electrical current. The electrical current travels through an electromagnet that consists of an iron middle with a wire enclosed. These cranes have a simple job, moving metals from one area to another. The magnet picks up metals, moves them where they're supposed to go, and the magnet is cut off, releasing the metals. A reliable power and automaton cable is necessity for this crane because of the constant current that is running through. Plus, it frequently turns on and off and subjected to hot usage. But we must know, every equipment has their advantages and disadvantages. Let's talk about advantages of using the electromagnetic crane. Firstly, it creates a safer lifting operation by providing a safe distance between operator and the crane, and allow remote operations from a safe distance with a full range of vision. Next, it increases the reliability and reduces manpower as slinging is not required. The lifting materials is also at more efficient rate, and it develops flexible adaptable solution suiting the range of load. However, for the disadvantages, as we all know, when we are using equipment involving magnet, it has a very high sensitivity. And for the electromagnetic cranes, the lifting capacity will drastically decrease as the air gap between the magnet and the lifted load decreases. The power consumption is also big. They heat up very fast, and due to this, higher heat generation loss of electrical energy. A continuous power supply is required to maintain the constant magnetic field. Last but not least, we can conclude that electromagnetic crane is very useful for the industrial department, as it is used to handle and move metals like steels and iron. If we use it accordingly, we can reduce the effect and more electromagnetic application can be created in the future. In addition, by using this crane, the manpower can be reduced and the lifting materials will be at more efficient rate. That is the end of my presentation. Thank you.